All right, boys and girls, we have one more in the lesson 8 or chapter 8 sections. This is 8-5, solving special systems. So we already kind of talked about a lot of what's in this worksheet. If you go back and look at my video talking about how many solutions, much of what we talked about there is going to have overlap here. Okay, so I'm going to kind of shortcut this one because really that's probably the better video to look at. I go really in depth on it. And I don't really want to rehash it here because I'd like to save my time. Okay. So first of all, I'm going to give you the brief rundown, but I would definitely recommend watching that video first. Okay. So we're talking about special systems now. So we've talked about lots and lots of times where you have two equations that end up making one solution. Two systems that make one solution. So I'm going to go in red. Okay. My first line, and I'm going to go in green. So this would be an example of a one solution system. Okay, they would have a solution here at that intersection point. Okay, what we're going to focus on though in this one is less problems that have one solution and the occasional kind of special case. Okay, so our two special cases, the first one is a no solution problem. So, oops, oh, that was good. Okay, oh, that's pretty good for me. Okay, so notice that these two lines, they are parallel. Okay, and parallel means no solution because there's no points where the graphs intersect. Since there is no intersection, there is no solution. Okay, so the next type, and this one seems kind of strange when you first hear of it. I think you guys probably remember when we first did this section. The last type is infinite solution, okay? And we only have infinite solutions if, let's say I'm plotting my two lines, and I go and plot my first one, and I get a line that looks something like this. Okay? Well, when I go to plot my second line, what would happen if I got the exact same line? And I'm going to do my best to trace this, okay? And my line is the exact same. If that's the case, that means that every point on this line, okay, the graphs intersect, the graphs touch, okay? So therefore, if it's the same line, that is infinite solutions. Okay, so that only happens if we get the exact same equation. So as you're solving these problems, you're going to see problems. Sometimes that'll be parallel, and sometimes that'll be infinite solutions, and you need to be ready when you see those. Okay, so let's go ahead and take a look at these first two. So again, I'm not going to rehash stuff that we've basically already done. This one's just graphing the system, okay? So you're going to take them, you're going to put them into slope-intercept form, okay? So for example, in this first one, the first equation is already in slope-intercept form. I would make this second equation, I would solve for y and get it into y equals mx plus b form. Okay, if you don't remember how to do that, again, go back to that 8-1 video. I do a ton of problems like that, so this is going to be a good place for you to go. Okay, so that's going to be consistent for 1 and 2. Take your equations, put them into slope-intercept form, and then graph them. And then you're going to give me the answers down here under solution. Okay, this one's going to be very similar. Okay, this time we're going to rewrite each system, and we're going to put them in y equals mx plus b form. Okay, and then we're going to state whether the system has one solution, no solution, or many solutions. So I want to point out a few things here. Okay, so when you are looking at equations, okay, so if I'm looking at any random equation, y equals 2x plus 5, I'm going to already put them in slope-intercept form. Again, you can go back to that 8-1 video and learn all about how to take equations and put them in slope-intercept form. But if I have two equations, okay, they will have one solution if the slopes are different. Okay, and it makes sense if you think about it, okay? Because if I draw a line with a certain slope, and I draw a line with a different slope, at some point, those two lines are going to cross, okay? If, let's say, I draw a line with a certain slope, and I draw another line with that same slope, then that's when I start seeing these these no solution or infinite solution kind of problems. So in this case, in my example here, this would have one solution because the 2 and the -4 are different numbers. Okay, so if you see two different slopes, you know there is only one solution. So for example, in number 3 here, okay, so I would take these equations and I would solve them for y, okay, and then I would just compare my slopes, compare the numbers that were next to x, and if they were different, then I would know I have only one solution. Okay, to find if you have no solution, okay, you are looking for two equations where this time the slopes are the same. Okay, so notice how my first equation has a slope of, let me change my highlighter, slope of -2. Okay, and my other equation is also going to have a slope of -2, but it's going to have a different y-intercept, a different b value. Okay, so slopes are the same, but the b values are different. So we have no solution if the slopes are the same, but the b value or the y-intercepts are different. Okay, and it makes sense if you think about it, because if I go back to my picture up here of a no solution kind of problem, you'll notice that where they cross the y-axis is not the same, right? They are at different points. So they have the same slope, they go up, they rise and run the same, but because they start from different points, they're never going to cross. Okay, so that was what gives us a no solution. Okay, and finally, the last one, this is the easiest one of all. Okay, this is the infinite solutions problem. And basically, that only happens if the two equations are the exact same. So if you solve for y, and you get y equals -2x plus 3, well, if your other equation is also y equals -2x plus 3, well, you have an infinite solution problem. Oh, I can't spell. Let's try that again. Infinite, Mr. Ferrari. Infinite solution if the slopes and y-intercepts are the same. Awesome. Okay, so that should get you through most of these first questions. If you're having trouble with the word problem, again, go back and look at some of those previous ones that we've done, okay? Because a lot of the previous worksheets had word problems. They're going to be very, very similar to these ones, okay? And the rest of the page is going to be very similar. You're just checking to see if the systems have one solution, no solution, or infinite solutions. Okay, and again, follow the steps from before, like we talked about over here. Turn your equations into slope-intercept form, and then just compare. Right, and I'm going to leave you guys on this page. So use this as your kind of reference page, okay? If the equations are the same, infinite solutions. If the equation slopes are the same, but the y-intercepts are different, that is no solution. And if the slopes are different, no matter what the y-intercepts are, if the slopes are different, then you have one solution. All right, that's going to end the video. Good luck.